for number 11. So now when we say we try to solve, remember the meaning of solving? Solve, solution, to find the value that makes a statement true. So so what we want is that we want to find a value of x that could make it equal to 0. We want to make it true. So what can we do to make it true? And we say, well, if you have two parentheses, if one of these two parentheses is equal to 0, then it will be true. If one of these two parentheses will be 0, then it will be true. And then we say, well, then just go ahead, set each one equal to 0. So we have x equals to -2. Because if x is equal to -2, and -2 plus 2 is 0. 0 times anything gives you 0. Are we okay for the first one? Why x is equal to -2? Using the same logic, we will go ahead and solve for x on the right-hand side, the other possibility. So x is equal to -5/2, because if x is equal to -5/2, then it times 2 will give you just -5. And then -5 plus 5 will be 0. So 0 times anything would give you 0. So again, keep that in mind, okay? When you see the word solve, it doesn't mean that just find the x value. It means to make the statement true. Okay, now, then let's go ahead and shift our focus to question 14. Now for question 14, so you will probably be tempted to do the following. You look at this. You look at this. You might be tempted to expand it to do the FOIL. You might be tempted to multiply the 2 into the parentheses. So how can you not be tempted to do any of the things that I just mentioned? Now, you may want to write this down on the side. Solve, right? It means get x by itself. Okay? I mean, you want to solve something, you want to get x by itself. If not, then you are really going in the wrong direction. So then you have a single x right here. So we say, well, how do you get x by itself? You have to strip things away. So the first thing that we will get away is the -5. So how do we get rid of -5? Add 5, right? So 8 plus 5 is 13. So so that +5, that -5 is gone. So we have 2 times x plus 2 parentheses square. And then the next thing that we will get rid of is the 2 right here. So we'll divide it by 2. So so we have 2 got canceled out. So x plus 2 square is 13/2. And then the next thing that we'll get rid of is the square. So and to get rid of the square, we need to do the square root. And don't forget that not only we need to do the square root, we need to do the plus or minus square root. Okay. On the number side, we have to do plus or minus square roots because we don't know if it's positive or negative. And then we will continue and say x plus 2, it's equal to plus or minus square root of 13 over square root of 2. And remember what we need to do? Oh, over the weekend. Now, I asked a question. Actually, I asked this question a long time ago, but I never really had the initiative to find out the answer. Remember we said that we do not want the square root in the denominator? Anyone had thought about asking the why question in the past? Anybody? Why we do rationalization? Nobody? So just do it because I told you to do it? Yeah? Well, so actually, I asked this question for a long time. I never really had the initiative to find out the answer. And finally, over the weekend, I typed it into the internet. I typed into Google and searched. So why do we want to get rid of the square root in the denominator? Well, if you put this into the calculator, do you know what value it is for square root of 2? Square root of 2, it's a pretty ugly number. 1.414, and then it never ends itself. It keeps on going. So the problem is that if we are dividing something, should we divide by an integer? Something that's easily seen, okay? It makes no sense that you are dividing by something, but that something, it's a never-ending number. So this is why we say we don't want a square root in the denominator. We want some sort of integers in the denominator. So square root of 13 times square root of 2, it's square root of 26. Okay, if they have the same root, the numbers underneath it, they can multiply together. And then square root 2 times square root 2 will give us, well, 2, because square root 2 times square root 2 is the same thing as square root 2 square, and the square root, they cancel each other out. And then one final step is to get the plus 2 away. So we minus 2 on both sides. Minus 2 on both sides. So you have negative 2 plus or minus root 2 over 2, root 26 over 2. Okay, so again, you want to get x by itself. You don't want to do the FOIL at the very beginning, because if you do that, you just have a lot more, you have more x's that you have to deal with. You have only one single x. Your job is to get x by itself. Okay. Now, I think if you go to the next page, you can go ahead and do this by yourself, as long as you know what the quadratic formula is. Okay, so go ahead, take a minute or two, do this by yourself. What's the quadratic formula? Quadratic formula is printed on the below, right? So you know the quadratic formula, it's x equals to negative b plus or minus b squared minus 4ac over 2a. And you can write down the a, b, c values so that you can plug in properly. What's the a value? 2. B? C? Okay. And if you remember what I said that when you substitute, make sure you use parentheses. And when you draw your root, and I'm not sure how big you write your numbers, but for the root, make sure you extend it long enough to cover all the numbers underneath the square root. 9 squared minus 4ac over 2 times a. So you have a bunch of numbers right here. Take care of them one by one. Negative 9 plus or minus 9 squared, it's 81. And then you have 4 times 2, which is 8. 8 times 5, it's 40. Okay. And then, well, there's a minus, and then there's a minus right here. So -4. And then you have -5, negative times negative, positive. Okay. Did you write down the -5? Yeah. Okay. And all over 4. Okay. So so x is equal to -9 plus or minus, what's 81 plus 40? Huh? 81 plus 40. 121. What's square root of 121? Okay, so we assume you that you know square root of 121 is 11. Okay, so so we have two situations. We have -9 plus 11 over 4. So we have -9 plus 11 over 4, or x equals to -9 minus 11 over 4. Yes. Can we just like leave it like this? Well, it's an easy number. Now, if it's a square root, you leave it like this. But because you can actually compute the sum or the difference, then you do the difference and the sum. So -9 plus 11, it's +2 over 4, which is 1/2. And then over here onto the right, you have -20 over 4, which is -5. So with the quadratic formula, you are going to find out that x could be 1/2 and x could be -5. Okay? Easy. Just substitute numbers. All right, next one, number 17. Number 17, x squared plus 3x minus 18. What form is this? What form is this? Standard form. Okay, what did you say?
I thought you were asking what we have to do now for factoring.
All right, so how do you factor this? Yes, we do factoring. So x squared must be x times x. So what two numbers would give you -18, and they added together will give you +3? -3 and +6, or either order. Okay, whichever order you have. So again, we try to solve for x. We want to get to we want to make the statement true. We want to make the left hand side 0. So how do we know that left hand side will equal to 0? Well, the left hand side will equal to 0 when the parentheses, each parentheses, it's equal to 0. So x is equal to 3. X equals to -6. Okay. So, yeah, it's very easily factored. Questions for number 17 and the one above? Okay. All right, so now let's look at the next page, number 20. So you have to make a graph. Okay, you have to make a graph, which is actually it's easier than that. Well, can you tell what form is this? How much information can you tell based on this vertex form in number 20? What can you tell? The what? We have the vertex. Let's go to the vertex first. What's the vertex? -2, 4. Okay. Can we tell the x-intercept from this form? You don't, you can't. Okay. What other information can you tell straight away? Is? Yeah, if you can tell the vertex, you can definitely tell the axis of symmetry, which is x equals to -2. So now let me go ahead and draw this out. So we have -2, 4 right here. If the vertex is right here, then the axis of symmetry must also be here. Okay. What information can also be extracted from this form? It opens down because of the a value. So a is -3, so we know that it's opening down. So and in that case, we have a maximum value of 4. It's opening down. Okay, so since it's opening down with a maximum value right there. And then if I ask you what's the range? Range. For the range, because it's a graph that opens downward, right? So so you know it's going to look something like this. Okay, it's going to look something like this. So so the range, which is the y value, will cover everything that's up to 4 and only up to 4, not more than 4. Now, how can we find the y-intercept? Okay, we plug in 0 into x. So we say the y-intercept is going to be making this 0. 0 plus 2, it's 2. 2 squared, it's 4. 4 times -3, it's negative 12 plus 4, -8. Because that's what happens when you have a y-intercept. X is equal to 0. Now for this one, because the test is not going to ask you something that complicated. So let's go ahead and draw these lines together. Connect these dots. I'm not going to ask you to find out the x-intercept, since the test doesn't ask you to get that part out. So yeah. So y-intercept, it's 0, -8. Domain, it's all real number, since it goes to left and the right, both ways. Okay. All right, now take a moment to work on number 21. Number 21. Okay, go ahead and take a look at 21. Convert that into a vertex, convert it into vertex form. Okay, how do you go from a standard form to a vertex form? Okay, so again, vertex form, it's y is equal to a x minus h squared plus k. So what's the a value? 1, because the a value here is the same a value over there. So we know a value is equal to 1, which is good. Okay. And if I want to find out the axis of symmetry, we say x is equal to negative b over 2a, negative of negative 2 over 2 times a, and that is 2 over 2. 2 over 2. And that's equal to 1. So we know something about the vertex already, which is 1 comma something. 1 comma what though? 1 comma what? How do you know? Yeah, so we can put in the 1 back in the original equation because since we know there's a point on the graph with an x value of 1, then the equation will definitely give you the y value. So we have 1 minus 2 minus 3, which is y equals to negative 4. So the vertex is 1 comma and negative 4. And as a result, the vertex form will be y equals to a, which is just 1. And then parentheses x minus h squared plus k, like this. Okay. Which one? Number 20. Well, the standard form is just multiplying everything out. So do you need to know that? Not that I can see, actually. Nope. 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 Okay. All right. So next page. Number 26 and 28. Now, we have done a lot of these already. And as I said, you always, number 26 is a strange one. Let me see. So let me go ahead and give you something a lot more friendlier. Could you go ahead and cancel this one out? Okay. Instead, write the following. Like this. X squared minus 11x plus 18. Okay. Yeah. So what you would do is to, what can you do? No, you don't. You want to keep the other side 0. You always want to keep the other side 0 because you want to find out whether it's above the x-axis or below the x-axis. Factor it. Whenever you see standard form, without being instructed, you have to consider the possibility of factoring. And if you cannot factor it, then you may consider other options. But factoring is really the first step you want to consider. So right here, so it could be x minus what? 9, 2. X minus 9, and then x minus 2. Okay, so x minus 9, x minus 2, and then and what I told you in class is that when you have it, just go ahead and graph it. Just go ahead and graph it. Okay, go ahead. Give you a few seconds. Make the quick graph on the left-hand side. What can you tell from the left? This is the root form. What does it tell you? The what? X-intercepts. Very good. So you have 2 and 9 right here. And with the standard form at the very beginning, you also know that the y-intercept is way up there at 18. So you can draw the graph very easily. And since, what do we want? We want the graph that it's greater than 0, right? Above the x-axis. So which part of the graph is above the x-axis? This part is above the x-axis. And this part is above the x-axis. So we say, well, what's the x value then? So for x, what x value would make the graph above 0? We say x is equal to, x is less than 2 without the equal, because there's no equal initially. Or x is greater than 9. It's an or because you can't have a number that it's going to be true for both conditions. X could either be less than 2 or greater than 9, so that the graph will be above 0. Okay? Questions for this one? Always factor. Always make one side go to 0, because that's how we can tell easily where it is above or below the x-axis. So if you look at number 28, so the first thing that we will do is to, because we need to have 0 on the right. Okay, and then if you see the standard form, you can factor it. So we have x and x, two numbers that can multiply to get you negative 24, 6 and 4, and in this case, it will be negative 6 and positive 4. So you can make a quick graph with the x-intercepts of 6 and negative 4. Okay, so something like this. And since we want the region, we want the graph to be less than or equal to 0. So we just want this portion of the graph. And this portion of for this portion of the graph, how can we describe the x value? Greater than or equal to negative 4, and yet it is less than or equal to 6. Okay, so so when you have x values being in between, you can simply express the values this way. Okay, you may also use interval notation if you want to. You can use interval notation, which is something like this. Since it is less than or equal to, then you use the bracket. Okay, that's question number 28. All right, number 29. For question number 29, again, you are seeing a standard form. Do you think you can factor this? What does it factor into? -3 and -1. So y is less than these, y is less than this parabola. And we have the x-intercept at 3. and x-intercept at 1, 0, 3, 0. Can you tell the axis of symmetry? 2. Can you tell the vertex? Well, we have to calculate, right? So so we know the vertex must have a x value of 2 because it is in between the two x-intercepts. So we can simply put the 2 back into the equation. So 4 minus 8 plus 3. 4 minus 8 it's -4. -4 plus 3 is -1. So and we also know that the y-intercept it's 0, 3. So we have this graph. But now, can you see I just made a mistake? A subtle one. Yeah, it should be a dashed line, right? Because it is just it's only less than without the equal sign. So I should not use a solid line. I should use a dashed line instead. Yeah. Okay. So so if you and which region are we shading? The one above or the one below? When it says y is less than the parabola. Yeah, below. Okay. Because y is less than means below. Okay. All right. So number 30, the one next to it. So you will be given a vertex form, but we ask the same question. So I mean, the first thing would be, can you tell the vertex? Okay, the vertex it's -3, -1 because again the vertex form it's x minus h, a times x minus h parentheses square plus k. Okay, so that means you can put down the vertex right here. All right, and now where are the x-intercepts? Okay, where are the x-intercepts? You will have to put the y equal to 0. So it's quite similar to what we did earlier. Find x, please. Okay, please find x. So we say, all right, how do we get x? Okay, we add 1 on both sides. And then we do the positive and negative square roots on the number side. And square root of 1 is still 1. And then we subtract 3. So -3 plus or minus 1. So the two numbers are x equals to -4 or x equals to -2. So the two x-intercepts are right here. Okay. The y-intercept, it's right here, 0, 8, because when you put in 0 into x, you get 0 plus 3, which is 3, and then square, you got 9. 9 minus 1, it's 8. So you can now make your beautiful graph. And then we say y it's less than or equal to. That means we'll shade the region we will shade the region below. And if it's above, then you shade the region. I mean, if it's greater than, then you shade the region above. If it's y is less than, and it's really literal, you just want the value that's less than. Okay. Now, things that are not included, well, actually, if you look at question 25 above, is it a quadratic? How can you tell if it's a quadratic or not? The second difference, right? So you just say, well, that's 4 minus 3, it's 1. 7 minus 4, it's 3. 12 minus 7 is 5. 19 minus 12, it's 7. 28 minus 19, it's 9. And then you do the second difference, which is 2, 2, 2, 2. And we say, yes, that's it's a quadratic. But now, we don't need you to write down the standard form. We just need you to know that if it is a quadratic or not. Okay?